Okay, now let's talk about dimension analysis. So I've got a question with me here, which is saying we have got the pressure is equal to the density times gravity times the height. Okay, so now let's think of this. Let's say we have been asked to say check that this equation is dimensional correct. Okay, given that P, the first one, this one is the pressure. Okay, then this is just basically the density, this is the acceleration due to gravity, then this is the height. Okay, now remember the rules of dimension analysis. So now when we talk of dimension analysis, we are talking about three things. Okay, we are talking about the length, we are talking about the mass, and we're talking about the time. So whenever we're talking about the dimension analysis, these are the only things which you are supposed to remember. Okay, now what I mean is when we talk of the length, we know that length, it is in meters. Okay, it is in meters. Then when we talk of mass, mass is just basically kgs. When we talk of time, time is in seconds. These are the SI units. Okay, but now when we are representing this information in terms of dimension analysis, where there is meters, we are supposed to put length. So this length is just basically I'm supposed to put capital L and then I put it in the brackets. Now, when I talk of the mass, I'm talking about the kgs. So this one has to be in, I say this is the mass. So I'll put capital M, then I put this. When I talk of the time, I'm talking about the seconds, but this one has to be in T, now the capital letter, then I put this. Okay, now what I want us to understand is that the equation which we have here, don't worry about the power 2 there. This power 2 which we have is the same as the square root. I can tell you that it's the same as P is equal to the square root of the density PGH. That doesn't have any impact actually. So we are going to ignore it. Okay. Now we want to see if the units are going to be the same. That is what we mean. Now when we talk of the pressure, we know that pressure is force over area. Okay. Then I'm going to put this one. I know that density is mass over what? Over volume. Okay. Then what is the kgs? Oh, sorry, the gravity. This g is meters per second squared. Okay, so I'm going to say, let me put this mass as capital M so that we should not be confused. Let me just say this is going to be equal to the mass over the volume. Then this one is going to give us what? G is going to be the meters per what? Second squared. When I say meters per second squared, it's the same as meters per second squared. It's the same. Okay, now let's talk about H. H is just basically meters. So I'm going to put meters. Now, I know that force is just basically mass times acceleration. Why am I resolving it into simple terms? Because I'm trying to come up with only these three. I want to dismantle everything so that I have length, mass, and time. That's all. Okay. So now what I'm going to have there is, I'm going to have this. I'm going to say that force is mass times acceleration. So I'm going to put mass times acceleration. Okay, but this mass I'm supposed to put it in what? In capital M, so that I should not be confused with the meters. So I'm going to say mass times acceleration over, this is going to be the same area. So I'm going to have this over V, I'm going to have this times this. So we want to make sure that the units which we're going to have on the left hand side, they're supposed to be the same as the units which we're going to have on the right hand side. Okay, so now we know that this it is mass. So mass is just basically in kgs. Okay, so I'm going to say in kgs times. Then what is I'm going to put this area as in what? It is also in meters. So meters I'm going to put M. Now I'm going to square it. Then now I want to come to acceleration. Acceleration, we know that it's also going to be meters per what? Second squared. I'm done with this part. Okay, then I come to the right hand side. I know that this one is also in kgs. Then volume is just basically meters per, or cubic meters. So I can say m to the power 3. Then times it. Then I can say that this m and this other m is going to give me m squared. So I can say that is going to give me m. Or if I don't want to confuse you, let me just put m on its own. Let me just say that is going to be m meters, and I have got him. This is going to be second squared. This is going to be meters. Okay, now from there I can get rid of this. Okay, now what I want us to think now is we know that if I say 1 over 2, this is the same as 2 to the power negative, or let me give you this. If I tell you that I have 1 over, or I say x, anyway, let me just put it in this way. I say I have 1 over x. This is the same as x to the power negative 1. Okay? Or if I say I have got 2 over x. Yeah, so this is going to be the same as now I want us to think like this. So this is what we have here. We have kg, then this guy is down here. So this is the same as if I put it in this way. I say this is the same as meters times to the power negative 2. I've just removed this one on the denominator. Then I also have meters. Okay, but I also have meters there. Then I'm going to have also what? Second. Now that second is going to be second to the power negative 2. This has to be equal to, I come to this one. So this one is going to be kgs times meters to the power negative 3. Then times I have got meters. So this meters and this meters I can put it in one, so that I say it's going to be meters to the power 2. I have just done this times this. But if you want, you can do it separate. Then I'm going to have times seconds to the power negative 2. Okay, now since I have that, I can now get the these ones here. I've got, where there's meters I'm supposed to put L, where there's kg I'm supposed to put M. But in most of the cases, the rules of dimension analysis, we are not allowed to do times here, there and then. So if I want, I can just say, to make things simple, I can just say this is going to give me meters times also meters, then times second to the power negative 2. Okay, so those are the rules. Now where there is m, where there is kg, I'm going to put capital M. So I'm going to say this is going to give me m, then I put it in this way. Okay, then times this is going to give me, I'm going to put, this is meters, so it's a length. I'm going to put negative 2. This is also length, so I'm going to put this. So this is negative 2, let's not forget. Then also have, this is going to be t to the power negative 2. Then this has to be equal to, this part I'm going to have the same. I'm going to have the kgs, which is going to be the mass, so I'm going to put mass. Then this one is going to be its length. Now this length to the power negative 3, I'm going to have another length. I'm going to have another length. Then I'm going to have t raised to the power negative 2. Now, what we have here, this is the same thing. This and this is the same. So I'm going to say this time, this one, I'm going to get L to the power 2. So I'm going to have M, or even here I can do it in advance. So I'm going to say this is negative 1, the same as I've got the same bases. So if I've got the same bases, you add the power. So it's going to be negative 2. It's going to be negative 2 plus this, I have got 1 plus 1, which is going to be negative 1. So I'm going to have M. Then here I'm going to have L to the power negative 1. Then this one I'm going to have just t raised to the power negative 2. Has to be equal to. Then this part here, this is going to be the same. M. And then this is 2. This is just the same as I have got negative 3 plus 2. On top, this is 1, 2. So this is the same. So it's going to give me 2. So I've got negative 3 plus 2 on top there. I'm going to get what? I'm going to get L to the power negative 1. So I'm going to have this. Then I'm going to have t raised to the power negative 2. So if we can check here, we have got M, we have got L to the power negative 1, L to the power negative 1, t to the power negative 2, t to the power negative 2. So meaning this is dimensional correct. So this is how we are supposed to check. Okay.